In continuing our discussion on the general aspects of crystal and LC filter products from Dynamic Engineers, the other very, very important aspect that is of high value to our customers, back to the 100%, almost 100% vertical integration. So we have the metal cans, as I discussed earlier, the metal packaging configurations, all done in-house with our in-house machine shop. The other aspect of the crystal filters is the fact that the Mesa blanks or the AT Cut crystal blanks, they come in as raw blanks. Our factory then base plates, cleans the blanks, then adds the initial layer of metallization called the base plate. Then the final plating process occurs on the crystal blank itself to put the crystals in the crystal filter. All of them are at a certain offset frequency. If 4 crystals are used, for example, in the design, all 4 crystals will be related to each other with their offset frequencies, with their characteristic impedances. What I mean by that is their C1, their motional capacitance, will be related to each other. In essence, the secret sauce at the heart of the intellectual knowledge for a crystal filter manufacturer is the relationship between the electrical parameters of the crystals used in the design. That will almost never be discussed with a customer, only in the sense if we are trying to explain parameter trade-off between the different critical parameters of a crystal filter. We might bring up some discussion of the theoretical design in order to better explain to the customer. But the very, very detailed relationship between each crystal as it's manufactured after the blank comes in is a core secret of the operation. So there are, believe it or not, filter houses, filter manufacturing operations that have no crystal manufacturing capability at all. They try to assume what the relationship is going to be between finished crystals. Then they buy finished crystals from the outside world. They think they're saving themselves cost. But what's really going on is they have to basically scrap all the crystals that they can't match up with each other inside a properly matched filter unit. So their scrap costs become very high. Whereas when you are plating, when you are doing the wet processing of the crystals in-house, you have the ability to do the wet process over and over again until you get the right electrical parameter relationships between the crystals. That saves cycle time, that saves scrap, it improves the ultimate distribution of performance of the electrical parameters because you control the wet processing of the crystals. Again, related to that 100% vertical integration, or nearly so, is the traceability of all materials used inside the product. For some military applications, they require 100% traceability. Here's a given production lot. What are the lot production numbers of the crystals used, the motherboards used, the inductors used, the core material in making the inductors? Our factory can trace back all the production lots of the actual materials to their origin. In the event there is some sort of field return or quality issue. Again, the customers are very appreciative of that capability. In the process of making a crystal filter, and again in another training session, we could have a 3 or 4 hour discussion on how to manufacture crystal filters, the manufacturing process flow. But let me say this, all the critical parameters are tested and screened throughout the assembly and test of the filter. All the crystals that are finished, the relationship between the 4 crystals, let's say if 4 crystals are used, they go into test fixtures to match up the crystals with each other. So if you've got an order for 100 pieces, each filter uses 4 crystals. Part of the process is matching the 4 crystals ahead of time with each other. so that each production unit in that 100-piece order has matched crystals up front before putting it in the assembly. So there's a lot of work done with technicians, all with 15, 20, 25 years experience in the business, who match up the crystals with each other for a given design and a given frequency. These crystals, as well as the final assemblies, are cooked at elevated temperature many weeks in total. A couple weeks for the crystal, a couple weeks for the crystal filter assembly. The reason being, in quartz crystal technology, cooking at elevated temperature takes out of the product a lot of the frequency shifting that could go on. So even though the cooking can take a few weeks of cycle time in the production process, those cooking processes are absolutely critical to making sure we have a stable product that ships to the customer and will experience minimal shifting over the course of the product over many years. In fact, our factory has been in business, in existence since 1970. Our factory has had 0 field returns from very high-end customers over the course of all these decades of shipping high-performance crystal filters. When you talk about these crystal filters, I want to refer to our RF system block diagram that is in the brochure. And the IF crystal filter, the intermediate frequency part of the radio, the wireless system, is where you'll find crystal filters. In the IF system, that is basically your passband is the channel spacing in the radio. So the kilohertz channel spacing for a multi-channel mobile radio, let's say, VHF, UHF, there's going to be an IF frequency associated with that radio. And again, the IF portion is going to be associated with the receive chain, the receive part of the radio system, the low power part, the milliwatts part. So the audio or the data or the voice that's coming in from the carrier on a VHF radio will first be upgraded, uploaded, uplinked to an IF frequency. So that information will be modulated onto an IF frequency of, say, 70 megahertz or 140 megahertz. There's a few very common frequencies for IF, 10.7 megahertz, 21.4 megahertz. That information will be modulated onto an IF carrier, and again, that dictates your channel spacing. So again, our factory is associated with making very high reliability military mobile radios, and that requires a lot of testing and retesting of critical parameters, temperature conditioning or annealing, so that frequency shifting is minimized once the customer receives the product. Basically a comprehensive quality system that matches all the military standards. Thank you.